In this video, I'll show you how to find the center, vertices, and foci for an ellipse. This is question 1. The question reads, find the center, vertices, and foci for the ellipse defined below. From the equation, we can distinguish three important things: our a, b, and center. Let's start with our a value. The a value is the largest of the two denominators. So in our case, the a value will be the square root of this 16. So a squared is equal to 16, and a is equal to plus minus 4. The fact that the larger of the two denominators is underneath the y tells us that this ellipse will be stretched vertically, as shown in this illustration. If the larger of the two numbers were underneath the x, then it would be stretched horizontally. Keep that in mind. That being said, b squared is equal to 9, and therefore b is equal to plus minus 3. All I'm doing is mixing and matching this formula to the standard equation formula. Another thing that's interesting is that in the standard equation formula, we have y minus k and x minus h. Remember, this is the standard equation formula for an ellipse where the center is not at the origin. This minus k actually tells us the y-coordinate of the center. Notice that right next to our y is plus 3. So if we rearrange this expression into saying y minus negative 3, notice that now we have y minus, this negative 3 becomes the y-coordinate of the center. So the center is defined as an x and y coordinate, so we have minus 3, and in our case here we'll have plus 5. So it's always the opposite sign of what you see. And that can be shown with a simple illustration. Let's pretend that we have a Cartesian plane, an xy plot, and we have a center at 5 and negative 3. So pretend that we move 5 to the right and 3 to the bottom. That's the center. And we're told that the a value, which is the major axis, and we also know that this ellipse stretches vertically. So it will go up 4 units. If this is negative 3, you'll have the vertex right here. And you'll also go downwards minus 4. Remember, plus minus 4. So if this is negative 3, we're at negative 7. So the vertices will have the same x-coordinate as the center. That's 5. And the y-coordinate will be plus 1. And for this point, we'll have minus 7. So this point is one vertex, and this point is the other. Now we're also being asked to find the foci. So we just found the vertices, we found the center. To find the foci, which exists over here and over here, I'm just doing an estimate here, you'll need to use the formula c is equal to the square root of a squared minus b squared. And the way that this formula is derived is pretend that we had a line stretching from the focus to the center, and another line stretching from the center to this part of the ellipse. That we know is defined as b, this we know is defined as c, and this part right here, the hypotenuse of this right triangle, is defined as a. The distance from the focus to this random point P is the same distance as a line stretched from the vertex to the center, which we call a. They turn out to be the same length. And so what we are using is a variation of the Pythagorean theorem. Let's fill in our a and b value. We know that our a value is positive 4 or negative 4. It doesn't really matter at this point because we're going to be squaring it. And our b value is 3. 16 minus 9, that is equal to positive 7. Let's use our calculator to find what that is precisely. We end up with 2.65. 2.65. This tells us that our focus for this point will have the same x-coordinate as the center, which happened to be 5, and the y-coordinate will simply be negative 3 plus what we just found. Also, this point right here will be 5 and negative 3 minus 2.65. And the reason why we're subtracting is because remember this number is plus minus 2.65. So let's go ahead and find out what this focus is, which we'll call F1, this focus, which we'll call F2. F1 has the coordinates 5, and using our calculator, -3 plus 2.65 gives us approximately -0.35, -0.35. And our second focus is 5, and using our calculator once again, minus, we get -5.65. And there you have it. We have officially found everything that they've asked for: the focus, the vertex, and lastly, the center. And there you have it. That is how to find the center, vertices, and foci for an ellipse. Make sure to watch question 2 for another example.